Hello there. This is our group's take to the calculation, manifestation, and designing of our antenna. Designing the antenna itself is a step-by-step process, so with each step done, we can continue on without any problems and further notice. So now, that said, let us now begin. Let's first start off with what we were given. As you can see, the frequency of ours is about at 54 MHz to 16 MHz, and the amount of directors that our antenna is meant to have is about 4 directors. We'll make use of the frequency first in order to find the first step into making and designing our antenna, which is finding the center frequency, which is represented by the symbol Fc. To first start off, let's look at the formula, of which is about at Fc of the square root of Fmin times Fmax. By replacing the values of Fmin with the minimum of our frequency, which is 54 MHz, and the Fmax, which is the frequency maximum, that being 216, we'll be able to multiply those two numbers first, which would be equal to 11,664 MHz squared, still having the square root, and by simplifying it, we would have the value of Fc equals to 108 MHz. Now that we found our center frequency, we will now proceed to the second step of designing and manifesting our antenna, of which is finding the wavelength. Wavelength is represented by the symbol lambda, and its formula is at lambda is equals to c over fc. C is the speed of light as a medium, and its value stands at about 3 times 10 raised to 8 meters per second. Now, by replacing Fc2 with 108 megahertz, and of course by substituting mega, of which is equals to times 10 raised to 6, you would have 3 times 10 raised to 8 meters per second over 108 times 10 raised to 6 hertz. Now the value of which will be about 2.77777778 meters. But that said value isn't finished yet, as we're trying to look for the actual measurements of our antenna, so we'll be multiplying it by 0.94 as we'll be minusing it by the 6% that we were told to. Now, by what I said, we would have the value of 2.611111111 meters. Now, since we found our wavelength, we will now be proceeding to the next step in designing and manifesting our antenna, of which is finding the length of the driven element. It is represented by the symbol LDE. Now, its formula is equals to lambda over 2, which is the wavelength over 2. And the value that we found for that said wavelength is at 2.611111111 meters. And now by replacing that, we would be having that same fraction with 2.611111111 meters over 2. And it would be totaling to the value of LDE is equals to 1.3055555556 meters. Now that we found the length of the driven element, we'll be continuing on to the fourth step in manifesting and designing our antenna, of which is finding the length of our directors. Now this symbol is represented by the symbol LD, however, it continues on from LD1 until the amount of directors that you were assigned with, of which ours, as I said in the beginning, is 4 directors, so LD1, LD2, LD3, and LD4. Now the formula starts with LD1 is equal to LD2 equals to LD3 and equals to LD4, which would be at 0.95 LDE. Now by replacing the LDE value with what we found, it would be equals to 0.95 times 1.3055555556 meters. And by finding that said value, it would be equals to 1.240277778 meters. And with that said value, we'd be continuing on to every single director. So LD1 is equals to that value, LD2, LD3, and LD4. Now that we found the length of our directors, we'll be moving on into the fifth step in manifesting and designing our antenna, of which is finding the length of the reflector. Its symbol is represented by the symbol LR, and its formula is equals to 1.05 LDE. And now by replacing the value of LDE with the number that we used for the length of the directors, which is 1.3055555556 meters, it would be totaling 2 LR is equals to 1.3708333334 meters.
With the value of the length of the reflector found, we will now move on the sixth next step in the creation of our antenna, of which is finding the spacing between the reflector to the driven element. It's represented by the symbol SR to DE. Its formula is SR to DE equals 0.15 lambda. By replacing lambda with the value we found for it, it will become 0.15 times 2.6111111 meters. By multiplying the two, we would have the value of SR to DE is equals to 0.391666667 meters. With the spacing between the reflector to the driven element found, we will now proceed to the seventh step in the creation of our antenna, which is the finding of the spacing between the driven element to director. It's symbolized by the symbol SDE to DE, has a formula of 0.10 lambda. By replacing the lambda just like the previous one, we would have 0.10 times 2.6111111 meters. By multiplying the two, we would have the values of SDE to D equals 0.261111111 meters. Moving on, it leads us to the eighth step in the creation of our antenna, which is finding the spacing between the directors. As my groupmate said before, we would have 4 directors in total, so the symbol of it is SD1 to SD2, and then SD2 to SD3, and the last one is SD3 to SD4. Its formula sits with the SDE to D1 over 2. By replacing the value of SDE to D1 with the value we calculated, of which is 0.261111111 meters, and by dividing it by 2, we would have value of 0.130555556 meters. With this value, we will paste to each of the SDs to SDs, as all have the same spacing between one another, explaining the equals between one another. Now we have reached the ninth and final step in the creation of our antenna, of which is finding the length of the boom. It's represented by the symbol LB and has a long formula of LB is equals to SR to DE plus SDE to D1 plus SD1 to D2 plus SD2 to D3 plus SD3 to D4 plus 0.0508 meters. The 0.0508 meters, if you're wondering, is the combined tips of our antenna, measuring each by 0.0254 meters. Now, going back, by replacing each of the symbols with the values we calculated for each of them, we would have an end result of LB is equals to 0.391666667 meters plus 0.261111111 meters plus 0.130555556 meters plus 0.130555556 meters plus 0.130555556 meters plus 0.0508 meters. And by adding them all, we will have an end value of LB is equals to 1.095244443 meters. Now, we have finally reached the end of our video. Now, with the values that we found, we were able to manifest it into really and be able to be done with our hand, but now fulfilling journey. Thank you so much for turning in with us both. Have a nice day and thank you for watching.